Okay, so this comes out of the 2022 Tech Allowed Calculus SAC, and we're looking at 3D and particularly E, how you might use a slider to come up with the values. So we have this function. I've got the function over here. I've taken the second derivative, hit simplify, and got this expression. And then to find out find all non-derivative for which the derivative is equal to 0. So going to make that answer equal 0 and solve for x. And I get those three answers, and they're the three answers there. Remembering that n are integers. So n is going to equal -3 or -2 or -1 or 0 or 1 or 2 or 3. So what we're after is to complete the following table stating the values of n for which the graph has a given number of points of inflection. So I'm going to think about what I've got here. N, if n is equal to 0, then I'm going to have x equals 0, x equals 0, x equals 0. There's only going to be the possibility of one answer, but that's if when n equals 0, it is a point of inflection. If n was equal to -1, then that doesn't exist, and I only have that answer. When n equals -2, that doesn't exist, etc. So let's build a slider and see what we get. So I'm going to jump over to graphs and tables. I've already entered my slider, and I'm now going to press interactive. I might come to 0. Analysis, G-solve. I'm going to use the idea of inflection, and I can see there are no points of inflection when n equals 0. So number of points, so n equals 0 is one answer there. Let's now consider when n equals -1. So -1. Analysis, G-solve, points of inflection. Now, there's not going to be any, because when n equals -1, the only possibility that I have is x equals 0, and when n equals -1, I've got an x in the denominator because I've got x to the -1. Therefore, it's going to be an asymptote. So if I go to -2, I've also got asymptote. -3, I've also got asymptote. -4, I've got asymptote at x equals 0. And remembering, if n is negative, these two can't possibly exist. Therefore, the only possibility is if x equals 0, and it's all asymptotic. Therefore, for no points of inflection, I'm going to have answers of -3, -2, 0, -1, 0, all the negative numbers plus 0. Now, let's see what happens when n equals 1. Analysis, G-solve, point of inflection. I've got at x equals 2, and I don't have any other. X equals 0 is not a point of inflection. Anyway, we're looking for the non-zero values. When n equals 1, I've got 1 minus 1, which is 0, and that's not a point of inflection, or 1 plus 1, which is 2. So when n equaled 1, I got 1. So that's why that's there. When n equals 2, analysis, G-solve, inflection. I can see 1 there, and I can see 1 there. And when n equals 2, I'll get 2 minus √2 and 2 plus √2, and that's what I like. I'm getting 2. When n equals 3, I'm getting analysis, G-solve. I'm now picking up a point of inflection at 0, 1, 2, 3. So when n equals 2, I got 2. When n equals 3, I'm getting 3 now because I'm getting 3 minus √3 and 3 plus root 3, and x equals 0 is giving me a point of inflection as well. When n equals 4, I'm now going to drop back to 1, 2. When n equals 5, I should get 3. Analysis, G-solve, point of inflection, 1, 2, 3, etc., etc., etc. So therefore I'm going to have 2 at all the even 2, 4, 6 and 8. And I'm going to have 3 at 3, 5, 7 and 9, because when n equals 3, 5, 7 or 9, this one here ends up being a point of inflection. And then we get the other two. That's how I can use a slider. You obviously can also, if you want to, just work in graphs and tables and bring this, and you can go keyboard, math3 given, n equals 0, and you can drag and drop when n equals 1, and you can still do analysis, G-solve, inflection, and find the points of inflection on your calculator. Okay, so that's how sliders can help do part E, part 2.